All right, let's jump right in. How can you possibly know the true, lifelong cost of something before you even build it? I mean, think about that. It's a massive question, one that impacts everything from a brand new jet to the skyscraper downtown. Well, the answer is being completely revolutionized by AI, and today we're going to break down exactly how.
It's a huge puzzle, right? We're not just talking about guessing the price of steel and labor for the initial build. No. You have to predict maintenance costs decades from now. You have to factor in future energy prices, what happens when things inevitably fail, and even what it'll cost to get rid of it at the end of its life. It's an incredibly complex calculation.
So, the official term for trying to figure all this out is life cycle cost analysis, or LCCA for short. Basically, it's the entire economic story of an asset all the way from the drawing board to the scrapyard. And for decades, honestly, it's been a field absolutely plagued by uncertainty.
All right, so let's dig into that. Why has this been such a ridiculously difficult puzzle to solve for so long?
The best way to picture traditional LCCA is like trying to use a really foggy crystal ball. You can kind of see the shape of the future in there, but all the important details, they're super blurry. Your assumptions are shaky at best, and a whole lot of it just comes down to, well, educated guesswork.
So what exactly makes that crystal ball so foggy? Well, for starters, the data itself is often pretty uncertain. Then, you've got dozens of complex variables. Think material costs, energy prices, labor rates, and they're all interacting with each other in unpredictable ways. On top of that, you have to somehow forecast failures and maintenance schedules over decades. And you even have to try and identify these so-called environmental hotspots, those points in the life cycle that have a huge environmental impact and therefore a huge cost. It's just a massive, tangled web of unknowns.
But now, we finally have a way to clear that fog. And this is where the AI toolkit comes in. And believe me, it is completely changing the game.
Now, the key thing to get here is that AI isn't some single magic wand you wave at the problem. No, it's more like a whole toolkit of specialized methods, and each tool is designed to tackle a different piece of that uncertainty puzzle. What it does is transform all those unpredictable variables into clear, actionable insights, the kind of stuff designers and engineers can actually put to work.
Okay, so let's pop open this toolkit and see what's inside. First up, you've got predictive analytics. This is pretty straightforward. It just uses historical data to forecast things like what your future warranty costs might be. Then there's something called reinforcement learning, which is really cool. It's all about finding the perfect trade-off. It's the tool that helps you figure out that, hey, maybe spending 10% more on better materials today could actually save you 50% in repairs over the next 30 years. And finally, you have Monte Carlo simulations. Just think of these like rolling the dice thousands and thousands of times to see every possible future. By running countless scenarios with, say, different energy prices or material shortages, you get a much clearer picture of the risks and rewards for any design you're considering.
Okay, so that's the theory. But how does this stuff actually work out in the real world? Let's take a look at a few examples.
And we're going to start in the aviation industry. This is a place where literally every ounce and every single dollar counts, especially when you're working with super advanced materials like carbon fiber composites.
Yeah. A recent study from 2023 found that by using AI, designers can now pinpoint those environmental hotspots we talked about, things like really high-energy manufacturing processes, and they can optimize costs around them even when the data isn't perfect. And what does that mean? It means we can build jets that are not only cheaper to operate over their entire lifetime, but are also way more sustainable. That's a huge win-win.
Okay, next up, let's jump over to engineering and construction. Specifically, we're talking about designing buildings in places that have to deal with earthquakes.
This is where that reinforcement learning we mentioned earlier does this incredible balancing act. The AI helps designers wrestle with that classic question, do we spend more money up front on a much stronger steel frame, or do we plan for potentially higher repair costs down the line? The AI dynamically adjusts the design to find that perfect sweet spot, and the result is structures that are both more cost-effective and, most importantly, way more resilient.
And for our last example, let's head to the manufacturing floor, a place where efficiency is absolutely everything.
And this chart, wow, it really tells the story. See, AI-enhanced tools let manufacturers analyze pretty much everything, from their energy use to their carbon emissions. And what happens? You see a huge reduction in material waste and financial overruns. You get much smarter predictions for warranty costs. It all leads to more sustainable and way more efficient production, right across the board.
But here's the thing. As powerful as each of these AI tools are on their own, that's not even the whole story. The real revolution, the thing that changes everything, is when AI gets integrated into a much bigger digital ecosystem.
Think about it like this. The old way? Everything was siloed. Information was all over the place, totally disconnected. Maintenance was always reactive. You waited for something to break, and then you fixed it. The new way is all about integrated intelligence. We're talking comprehensive health monitoring of an entire system, predictive strategies to stop failures before they even happen, and dynamic, real-time cost tracking.
This whole process is what people call the digital thread. It all starts with sensors and IoT devices out in the world, capturing just massive amounts of data. Then all that data gets fed into the AI for analysis. The insights that come out of that are then visualized in these incredible systems, like digital twins, which are basically living, breathing virtual copies of a real-world asset, or in what's called building information models, or BIM. And those models then guide what we do in the real world. It becomes this continuous loop of data, insight, and improvement.
Okay, so let's pull all of this together. Why does this matter so much? Why is this shift from that foggy crystal ball to a clear, data-driven roadmap such a big deal?
Really, it all comes down to this one crucial point. It's a fundamental shift away from reactive guesswork and toward proactive, data-driven prediction. We're literally moving from just hoping we got the cost right to actually modeling the future with incredible accuracy.
So, what are the big takeaways here? First, AI is making the super complex cost analysis not just possible, but accessible and accurate. Second, that enables much more sustainable and cost-effective designs right from day one. Third, integrating all this with digital twins and BIM, that's quickly becoming the new industry standard. And the result of all this? Less waste, lower costs, and safer, more resilient infrastructure for all of us.
And all of this leaves us with one final, pretty big question. For decades, our ambitions, what we thought was possible to build, have been limited by uncertainty and risk. But now, if we can accurately predict the entire life cycle cost of pretty much anything, what will we finally have the confidence to build next?